This problem as well can be looked at as a dimensional analysis problem because we've got to take a look at the units we have, right? We're given the density of gold at 19.3 grams per cubic centimeter, and then we're given the mass of this and asked to find the density, or the volume of this, sorry. So again, looking at the units that we have and the units that we're looking for. And so I would start with the unit that just has one, the measurement that has one unit associated with it. So there's our mass. We want to multiply our mass by something that leaves us with a measurement of volume because we're looking for cubic centimeters. The only thing we can use that connects our mass to our volume is density, right? And we can read this density, even though it's written as 19.3 grams per cubic centimeter, it's the exact same thing. If I said for 1 cubic centimeter, I had 19.3 grams. We can use that ratio either way, depending on what we're trying to do. So here we want grams to cancel out. So I'm going to say, okay, I've got 19.3 grams for every 1 cubic centimeter. Here, grams will cancel out, and then when we divide through, we're going to be left with cubic centimeters. So I've got 352.46. I'm going to divide that by 19.3, and I come up with a volume of approximately 18.26, so I'll call that 18.3 cubic centimeters. If you need to report this in scientific notation, it would be 1.83 times 10 to the 1 cubic centimeters, or 1.83 E1 cubic centimeters. I would go with 3 significant figures based on this number here has 3 significant figures. We're just multiplying and dividing. This number here has 5 significant figures, so I would go with 3 significant figures based on that number provided there. But again, it's a lot of just looking at what units do I have? I have grams. What units do I want to get to? I want to get to volume, cubic centimeters. How can I connect those two? Density. Density relates mass to volume. That's the bridge I'm going to use to get from my mass to my volume of this sample.